Hello, guys. So today we're doing some more trig functions. We're going to explore a little bit more into this. Hopefully, you guys got your graphing calculators either downloaded on your phones or you went by the school and picked it up. Um, Also, don't forget to pick up your books and your access codes from the school. Okay, so let's just jump right into this. So last time we were doing trig ratios. So let's say we want to find sine of A. So right here, this is our A angle. So sine means we're gonna go opposite. Opposite is 7 over hypotenuse, which would be the hypotenuse would be 25. Cosine of A would be adjacent, which is next to, so it would be 24 and 25. Tan would be opposite over adjacent. So this would be 7 over 24. Okay. So you always got to be cognizant of what letter they're asking for. Okay. So be careful. Sometimes we're so used to say doing A, and we start working A, but the problem's actually asking for C. So you got to be careful with that. Okay. So right here, sine of C means I'm starting right here. Opposite would be 9 over 41. Cosine would be adjacent, which would be 40 over 41. And then tan would be opposite over adjacent, 9 over 40. So right now, go ahead, pause the video, do number 3. Okay, so I'm hoping you guys got number 3. I'm not going to go over it. I want you guys to try it on your own, okay? So now sometimes they'll ask you, um, you have cosine 52. What would be the equivalent to cosine 52 but in sine function? So there's a way of doing this, right? And we're about to figure it out. And what we need to do is for any angle, I put A, right? So but it's for any angle. So any angle, so in this case any angle, our angle here is 52. There's actually co-function values of complementary angles that are equal. Meaning if you have cosine of 52, to find the sine of cosine 52, you take sine 90 and subtract the 52. So to convert cosine, which I have right here, to sine, all I would do is I would go sine 90 minus 52, and I get sine of, let's see, 38 degrees. So cosine 52 will convert to sine 38. So we just got to kind of remember this. So sine converts to cosine, cosine converts to sine, tan converts to cotan, secant converts to cosecant, cosecant converts to secant. So now, what do you think cotan equals to? So think about it. Bop, 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 bop. You guessed right. Cotan will go to tan, right? And the idea stays the same. So it'd be 90 minus A. Okay, and A is whatever angle they give you. So whatever angle this is. Okay, so it's not too difficult. You just kind of 90 minus the number, right? What's difficult is remembering the pairs. So which two are paired up, and for the most part, it shouldn't be too difficult. Okay, so let's practice. So we just did this example right earlier. Um, so what about tan? So we know tan is cofunction, sorry, is cotan, and we're going to go 90 minus 71. So we would go cotan of 90 minus 71 is 19 degrees. That's it. And we're done. So right here, secant is cofunction is cosecant. And that one would be 90 minus 24. So cosecant of, let's see, 66. And that's it. So on your homework, guys, you might get one or two of these. Just refer back to this, guys. You want to refer back to this page, just in case you forget any of them. Okay, it's good. It's good. Good practice. Okay. Um. Oh, let's take a little trip down memory lane. Let's go back to geometry real quick. So in geometry, we had these two triangles, very special triangles. In fact, that's what they call them, special right triangles. And one of them was called the 30, 60, 90, and the other one is called the 45, 45, 90. And what was special about them is that these are some triangles that kind of pop up quite a bit, right? When we're building architecture or design, a lot of people like symmetrical stuff, right? So they do like squares, they like equal sides, stuff like that. But once you start cutting those squares in half and thirds or whatever, well, we start getting these 30, 60, 90 angles. And so over time, over the many years, thousands of years of just geometry and architecture and math, we always come up, we always bring these two triangles up all the time, you know. It's very rare that we bring up a scalene of, 10, 40, and I don't know, 130, right? Like nobody ever talks about those. But they bring up these 45, 45, 90. In fact, if you probably look around your house or just look around, when you're driving around, you probably see these triangles or these structural figures that have these triangles in them. So here's a little little brain teaser. I want you to pause the video. Okay? I want you to pause the video, and but while the video is paused, I want you to try to figure out the area of this triangle. So you're gonna get two of them. And I want you to figure out the area of this triangle. Okay? So pause the video, figure out the area of both triangles, and you know what? I'll even give you the formula. So area of a triangle is 1/2 times the base times the height. Okay? So hopefully that's enough hits. So pause the video, try it, and we'll go from there. Okay? Ready? Set, go. Pause. And we're back. So let's do the area of this triangle. So we have 1/2 times the base times the height. So in essence, we have x squared times square root of 3 all over 2. So that's, we found it in terms of x, right? And this is for the 30, 60, 90 triangle. What about the 45, 45, 90? So that one's x times 1/2 or x squared over 2. 45, 45, 90. Ta-da! So you're probably wondering why Moreno's bringing up some old school geometry stuff, right? So the reason for it is that these degrees, this 30, 60, 90, this 45, 45, 90, these are degrees that always pop up. Okay, so like I was saying, they pop up in triangles a lot, so they're always going to also pop up in trig functions. So we have these special numbers assigned to them, right? So we know sine of 30 degrees is going to be 1/2. Cosine is going to be square root of 3 over 2, and so on and so forth, right? So this is a little chart, a little little chart that I made for you guys that I would say don't have it memorized because it's kind of hard to memorize all of them, but keep this chart handy. Bookmark this page in your notes because this is something that whether you're doing pre-cal or you're doing calculus, this is going to come up. You're going to have to find out what tan of 45 degrees is. And sometimes you're going to deal with it so much that you're going to just remember it off the top of your head. Like, oh yeah, it's just one. Okay. So if you don't know this or if they don't come to you easily, go ahead and copy this down. Make sure you have it and make sure you have this out when you're doing your homework because your homework questions, this is going to help you drastically. Now, there's actually a trick on this. You could do it off of the hand. And I really wish I could have done this class live so I could show you the little hand trick. But I can't because I have a training to do. So I want you guys to, I know you're on YouTube right now, but go to another YouTube channel, video, and Google or you search in the YouTube exact trig values dash hand trick. It's a fantastic video. It's pretty much going to show you everything I would have showed you in class, okay? Of the way of doing it in class, okay? Uh, I just, I don't know how to do computer little animations like how she does. Uh, so that's that. I'll let the pros do it, okay? Now we also have reference angles. So reference angles is any angle that's bigger than 90 degrees, but it's on the 360 degree playing field, right? So it's in one of the quadrants, whether it's quadrant 1, 2, 3, or 4, and we want to find the reference angle to it. So what we do is we have this little cheat sheet. So if it's less than 90, well the reference angle is the angle itself. If it's greater than 90 and we know it's in quadrant 2, what we do is we take 180 and we subtract the angle that they give us. Okay? We subtract the angle that they give us. Okay? So be careful with that because it sounds a little tricky, but it's not so bad. Quadrant 3 is you take the angle and then you subtract 180. And you're thinking, wait, isn't that the same as quadrant 2? Yes and no. Quadrant 2, the angle will be bigger than 90, but less than 180. So think of it, guys. Bigger than 90, less than 180 would be like 123, 145. But in quadrant 3, we're going to have angles bigger than 180. They're going to be bigger. They're going to be like 205, 235. So when they're that big, then that means the bigger number gets subtracted by 180, and that becomes your reference angle. When you're in quadrant 4, you're going to have angles that are bigger than 270 degrees. So angles like 300, 315, 345, those would be in quadrant 4. So we take 360 and you subtract the angle that's given. Okay? So I know this might sound a little confusing, but we're going to do some practice problems. So look, 207. 207, bigger than 90, so it's not quadrant 1. Bigger than 180, so it's not quadrant 2. It actually falls in quadrant 3. So what do we use? We're going to take the angle and subtract 180. So we're going to go 207.3, and we're going to subtract 180 degrees. So we bring down the 3, bring down the 7. Okay, right here we borrow, boom, boom, boom. This becomes a 10. So we get 27.3 degrees. And that is our reference angle. Ain't nothing to it but to do it. Okay, next one. It's 150. So 150 is bigger than quadrant 1 because it's bigger than 90, but is that bigger than 180? So it's actually in quadrant 2. So what do? We take 180 and subtract the angle given. So we go 180 minus 150, and our reference angle would be 30 degrees. Okay, what about 311? 311 is bigger than 90, bigger than 180, bigger than 270. It's actually in quadrant 4. Okay, so that means we're going to take 360 and subtract the given angle. So we go 360, subtract 311. Okay, this becomes a 5. This becomes a 9. 5 minus 4, 4. And this is now my reference angle. So why is this even important? Kind of seems like it's basic math. Well, the reference angle is important because when we're doing our trig ratios, sometimes we're going to be in quadrant 3. And when we're building our little triangle right here, we want to know this angle. And if we put angle 210, it's going to be, I don't want to deal with big numbers. I want to deal with small numbers that I know. And guess what? 30 degrees goes back to our table. Look, 30 degrees. Look, it pops up all the time. I'm telling you guys, these numbers are going to be popping up all the time. So if we wanted to know what sine of 30 is, oh my goodness, can we almost anticipate what it's going to be? We could almost anticipate. It's like, it's so easy. It's there. So what I want you guys to do right now is use your hand trick or use the table. Find out what sine of 30 degrees is. So pause the video, look at your chart, try the hand trick, sine of 30 degrees, ready, set, go. And we're back. So what is it? 1/2. So sine of 30 degrees is 1/2. So what do you think sine of 210 degrees is? Do you think it would be 1/2? Here's the $1,000,000 question. Does it stay 1/2? Done, 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 done. Wait, done, wait, done, 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 done. Okay? What I want you to do right now is I want you to pause the video, find somebody from the class, and I want you to text them. Does it stay 1/2? Does sine of 30 stay? Does sine of 210 stay 1/2 just like sine of 30? It's very interesting. Let's see. Ready, set, go. Your friend should have told you no, it does not stay 1/2. And it's something that I discussed last class. We kind of discussed this that I had to make a video discussing my little error. Remember, guys? Because we're actually in quadrant 3. And because we're in quadrant 3, this is 1. Our hypotenuse is 2, right? So it is 1/2, right? Opposite over hypotenuse. But since it's in the quadrant 3, this 1 is actually negative because it's going down. So that's the only thing we got to remember. We got to remember that a sine of 210 is in quadrant 3. Now get this, check this out. We could have used our chart, right? We could have used our chart. We got the 1/2, right? We got the 1/2. Yeah, bam, for sine of 30. It's the reference angle sine of 210. But check this out. Remember last last class notes? Oh, where are they? Oh, forgot. Remember last class notes that we said, where is it? Where is it? Sine, when we're talking about the quadrants and we're looking for a sine of 210 in quadrant 3, it has to be negative. Check that out. It's all coming together. So we have to be cognizant, guys. We have to make sure we know that we're in quadrant 3, and whenever we're in quadrant 3 and we're dealing with sine, it's going to be negative. So now, what is cosine of 210? What is tan of 210? Well, now we can kind of figure it out, right? Like we know cosine of 210 would be adjacent over hypotenuse, and tan of 210 would be also adjacent. Opposite over adjacent, right? And we already know we have our triangle here. So guess what? All we need to do is figure out what this missing side is. And that's just Pythagorean theorem, guys. And I mean, of course, we could use our co-functions and all that good stuff, but this is something that we could just do, right? We go 2 squared minus 1 squared and take the square root. So we have 4 minus 1, which is 3, square root of 3. So this is just square root of 3. So that means cosine of 210 is square root of 3 over 2. Tan of 210 is opposite, which is negative 1 over square root of 3. Now here's the thing, guys. We can now verify. We know cosine of 210 is like saying, actually, before we go move any further, we actually need to verify the positive or negative of each one of these, right? We need to make sure we're in the right uh, positivity, right? We have the right sign. So if we're in cosine in quadrant 3. So let's go back to our notes. Cosine of quadrant 3 is gonna be negative, and tan of quadrant 3 is gonna be positive. So what did we do wrong? And I'm already gonna tell you. Square root of 3. Look, it's going this way. This is actually the negative side. So this should be negative, and this should be negative. And guess what? Negative times, negative divided by a negative is 1 over square root of 3. So now we have the correct signs. We have our negative cosine, and we have our positive tangent. So we're good. So let's verify the angles now. Sine of 30. So let's see what cosine of 30 is. And I think that's on this page. Cosine of 30. Oh, look, square root of 3 over 2. Square root of 3 over 2. What about tan of 30? Let's see. Tan of 30. Square root of 3 over 3. Bum, 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 bum. Holy. Why is this wrong? Guess what, guys? I forgot to rationalize. Remember, I said that mathematicians do not like to see square roots on the bottom. So we have to multiply by square root of 3 to so this is actually multiplying by 1, right? So the square root of 3 divided by square root of 3 is just 1. But this is going to help make things more pleasant on the eyes of mathematicians, because we don't like square roots on the denominator. So we rationalize it by saying square root of 3 divided by square root of 3, which becomes square root of 3 over 3. And that is, lo and behold, in our little chart. So I'm telling you guys, it's important. It's important to keep, it's important to keep these notes handy, okay? They're good. The little charts are good. Continue to go back and look at them, guys. Okay? There's no shame in the game to look at the charts. You don't have to have them memorized right off the bat. Is it good to memorize them? Sure it is. Do you have to? No. You have your notes. That's why we take notes. Okay? So don't be like, oh, I need to be able to memorize it for the quiz, for the test, or for life. Guys, relax. You're learning. There's a learning process. You're not going to learn it right off the bat. Just keep the notes handy, keep the chart handy, okay? And always refer back to it. So once you get your answer, go back and check. Check the little things, okay? We know that we have a chart to check the degrees. And we also know we have a chart on 5.2 to check the positive and negative signs, okay, of each quadrant. So it's very important that you check those, okay, guys? All right, let's go to the next page. Okay, so Now we gotta kind of mush everything together. So like pretty much everything we learned in 5.2, everything we learned today, we're kind of mushing it together. All right. So we have to find an angle measure given a specific interval and a function value. So let's say we have this right here. Bap, bap, right? So we have an interval from 0 to 360. Okay, awesome. Wow. We have so much to choose from now. We have quadrant 1, 2, 3, and 4, right? Now we have cosine beta is negative square root of 2 over 2. Hmm. Maybe we could use our chart to figure out some stuff. Okay, so we know cosine is negative. Okay, we also know square root of 2 over 2. So let's go to our chart. Let's first figure out square root of 2 over 2. Maybe we can find the degrees. Okay, we'll go to our chart. Cosine square root of 2 over 2. Oh man, look right here. Bam. We get it right here on the money. So we know beta is going to be 45. We know beta is going to theta is going to be 45. So we already know this part. It's going to be 45. Something 45. Okay. Okay. So we know cosine 45 is square root of 2 over 2. But look, we have this negative here. So that means we have to go to our 5.2 notes to figure out in what quadrants is cosine negative. So let's go to our 5.2 little chart. Cosine is negative in quadrants 2 and 3. 2 and 3. So let's keep a note on that. Let's note that. Okay. Oh, I already did. Quadrants 2 and 3. So that means the angle, because remember, this is the reference angle. This is the angle after we subtract either the 180 or the angle from 180. So we know it's in quadrant 2 and 3. So that means it's got to be bigger than 90 and all the way to, what is it, 270. Okay? But remember, for quadrant 2, we're going to take 180 and we're just going to subtract 45. Why do we subtract 45? Because we know our reference angle is 45. So we want to find the original angle, which in this case would be, oh, look at that. I already did the math. Okay. So I'm going to scroll down this way. So we have it right here, 180 minus the angle. We know the reference angle is 45. We figured that out. So we subtract 180 to both sides. Bap, bap. We get negative 135. Because we're subtracting, we got to do it. Since we have a negative data, divide by negative 1, divide by negative 1, and bam, look at that. 135, okay? So I'm going to just erase this, erase this, erase this. We don't need that. I'm going to zoom in. Okay, so now to find quadrant 3. We know our reference angle. We know it's 45. We saw it from the chart, okay? The original angle is what we're looking for. Minus 180 will give us our reference angle. So kind of working backwards. So how do I get rid of minus 180? Plus 180. Plus 180. And we get our second reference angle. 225. Ain't nothing to it but to do it. Okay. So let's work some problems out. So we have sine theta of 1/2. I think we already did this one, but let's try it again. So sine theta 1/2. Let's first figure out the reference angle. Okay. So 1/2. Let's go to 1/2. 1/2, 1/2, 1/2. 1/2. Bam. Sine of 30. So that means our reference angle is going to be sine of 30. And that's 1/2. Now we have to figure out when is sine negative. Sine is negative from, let's look at our little chart. Sine is negative. I'm going to erase all this. Sine is negative in quadrants 3 and 4. So I'm going to just make a note of that. Put it right here. Quadrants 3 and 4. So that means my angles have to be bigger than 180, but smaller than 360. So that means what I'm going to do is I'm going to have my reference angle is equal to the angle I'm looking for minus 180. This is for quadrant 3. Okay, so if you guys don't remember, we could go back, scroll back. It's right, is it right here? Quadrant 3. Reference angle, which we know is 30. The angle minus 180. The other one is reference angle, what we know, 360 minus the angle. Okay, where are we? So we add 180, and we get our angle to be bat 8, 9, 10, 11, bat 210. So we get sine of 210 degrees. But we're not done because we need the second one. Remember, there's two, quadrant 3, quadrant 4. So quadrant 4 works very similar. We put 30 equals to 360 minus the theta. Okay, we subtract 360 to both sides. I hope you guys can see the blue because it's kind of light. And then right here, we have a negative theta, so we divide by negative 1, and we get sine of 330 degrees. So we get our two answers. Bada boom, bada bing. Okay. Okay, last one. Okay, well, not last one. We got one more, right? Two more. But last example, secant theta square root of 2, negative square root of 2. So let's go to our chart. Secant square root of 2, bada boom, bada bing. That means our reference angle is going to be 45 degrees. So 45 degrees. So we come back. So our reference angle is going to be 45 degrees. Now, when is secant negative? So now we got to go to our 5.2 notes. Secant is negative in quadrants 2 and 3. Quadrants 2 and 3. So that means quadrant 2, sorry guys, that was my son, and 3. So that means I'm going to have 45 equals to 180. Let me write that a little bit better. Quadrant 2 means I'm going to have my reference angle to equal to 180 minus theta. And quadrant 3 would be my reference angle equals to theta minus 180. So we subtract 180, that gives us 30 negative 135. Yes. And then divide by negative 1, So our angle is 135 equals to theta. So then we would put secant 135. That's our first part. Now our next part is we just add 180 to both sides so you can't see that plus sign. There we go. Plus 180 plus 180. So 180 plus 45 gives us a grand total of 225. Okay. So now we have our two answers. Secant 225. That's a 2, guys. I know it's kind of hard to see because of the black. Okay. So we're almost done, guys. So I'm hoping I'm not going too fast. Last but not least, a little word problem. So uh, this is just pretty much you take the problem situation they give you, and you kind of just plug in what you know. So sometimes they'll give you this like a resistance problem. Okay, so they tell you that there's a force that is being applied to a car. It's usually a car going up or down a hill. Okay, so it says the weight of the vehicle times sine of whatever degree the hill is at. So usually it's going up a hill at a degree of like 35 degrees or 45 degrees, or it's going down a hill 35 degrees, 45 degrees, right? So all you do is you just kind of plug in what you know, and then you just kind of type it in the calculator, right? And sometimes teachers and professors won't even ask you to plug it in the calculator. They just kind of want to see if you know how to set it up properly. So, because this is where they get you. Because if the theta is bigger than zero, then you know it's going to be positive. Okay. If it's moving downhill, it's got to be negative. Okay. So they won't. That's something that the problem situation won't tell you. They'll ask you just set it up, and it says it's going downhill 30 degrees. You got to make sure you get that right. You know what I'm saying? That negative. So just be careful with that. Okay, so uh, don't don't um don't overlook it. Don't think, oh, this is easy. I just plug in 1,000 pounds or plug in 2,000 pounds and I'm done. Just be careful, okay, guys. Just watch what it says. Did we do a problem? Oh, I didn't. I should have done one, but this one, guys, I'm not too sure if I asked any of these type of questions on the homework. I wanted to go over it because I know you'll see this later on. They'll give you a resistant. I don't think I put any of this in the calculator in the homework, but it's really just plug and play. Just plug in what they give you, and then just calculate. So usually it'll tell you the car's 1,000 pounds and it's going up 45 degrees uphill. So all you literally do is put F equals 1,000 times sine of 45. And you literally put that in your calculator, and then boom, it gives you the force. So um, it's really not that like difficult as far as calculations, because you just kind of plug in what they give you, and you just type it in the calculator. Okay, just be careful with this. When it's going downhill, it's usually a negative number. Okay, all right. So that's it, guys. I'm hopefully this video helps you guys out tomorrow, or on your notes and on your homework. Please email me if you have any questions or comments or concerns. Um, don't forget, check the due dates on when the homework is due. And don't forget to do your 5.2 homework and your 5.1 homework, okay? They're all due the same day. So you have 3 homeworks to do. Let's get them done. All right. Have a good day.